Hello, everyone, and welcome to the Circuit Breaker PSC Ethereum Foundation Workshop, Semaphore, the Power of Anonymity. Joining us today is Vivian Plasencia, who will be taking us through this session. And with that, I'll pass over to Vivian to get the session started.
Thank you so much for the invitation. Let me share my screen. Hello, everyone. My name is Vivian Plasencia, and I'm a software engineer in the Privacy and Scale Explorations team at the Ethereum Foundation. Today, I will be talking about Semaphore, how can you use it to build zero-knowledge application, and some use cases, and a bit more. So this is the structure of the application. We will start with what is Semaphore, then we will talk a bit about some use cases, then the three main components of Semaphore: identities, then groups, and then zero knowledge proofs in Semaphore, which are the signals, and also how to integrate Semaphore into your project, and the architecture of a Semaphore application. And I will show some code during the presentation. Let's start with what is Semaphore. So Semaphore is a zero-knowledge protocol that allows users to prove their membership in a group and send signals such as votes, feedback, or any other text message without revealing the user's identity. This means that signals have no connection with identities. It also provides a simple mechanism to prevent double signaling, which means that you cannot verify the same signal, the same proof twice. And Semaphore is a public good project, is free and open source, so everyone can use it and contribute to it. Let's talk a bit about Semaphore use cases. So here is, you can see a link to the projects, some projects that other developers have built with Semaphore. And here is another link for ideas to build with Semaphore. And one example of project using Semaphore is Pandada. There was a workshop earlier. So which is an infrastructure to manage privacy preserving groups. So developers use Semaphore for many use cases. They use it sometimes for identities and sometimes for anonymous signaling. So yeah, you can find more about it in the list of projects here. The first part to interact with the Semaphore protocol is to create an identity. So an identity is made up of two secret values, which are the identity trapdoor and the identity nullifier. And there is another public value, which is the commitment. So the Poseidon hash of the trapdoor and nullifier is called identity secret, and the hash of this identity secret is called the commitment, which is the public value here that you can see here. And the identities can be created using a JavaScript library. You can create two types of identity. One is a random identity, which you will not pass any parameters in the identity class. And you can also create identities using a secret message. So these identities are called deterministic identities, and you create one passing a parameter in the identity class. You can also export your identity so that you can use it and import it later. Here is the link to the documentation with more information about the identities. There are also groups, and groups, you can think a group is like a set, is like an anonymity set, and it's a binary Merkle tree in which the leaves are the identity commitments, and all the other nodes in the tree are hashes of their two child nodes. And you can find more information about the groups in the documentation in the groups page. The Semaphore groups can be created off-chain with the JavaScript library or on-chain with the Semaphore contracts. Here you can see how to create a group with the JavaScript library, and also the other box you can see how to do it with the Semaphore contracts. And after creating an identity and joining a group, users can anonymously prove that they are members of that group and send signals. And to generate a valid proof, we need an external nullifier, which can be used to prevent double signaling. So this external nullifier is hashed with the identity nullifier to create and this hash is used to prevent double signaling. So, for example, if you want to create a voting process, if you want voters to vote only once, you can use as an external nullifier the group ID, so that the users, when they generate a proof, you will hash the protocol will hash the identity nullifier of that user, and also this external nullifier. And since the external nullifier is always the same, every time the same user create the same proof, create another proof, they will not be able to verify it twice. So because these hash are saved on chain, so you cannot verify the same proof twice. You can find more information about these proofs in the documentation page related to that. Zero knowledge proof can be generated off-chain with the JavaScript library, but they can be verified both off-chain and on-chain. So the proof generation is always off-chain because this process uses the private values of the identity. So it's better to generate them always in a front-end app, so that in one device, so that only the user owns his private values, their private values. So this way you can generate the proof and verify it with the JavaScript library, and the other box you can see how to verify it in the contracts. To start using Semaphore, you can find 3 ways to integrate Semaphore in your project. One is the CLI, the other is the boilerplate, and you can also install the packages manually. So let's start with the CLI. So you can use npx to do everything, or you can install it globally using npm. And you can create a new project using the create command, and there are 3 templates. One is called contract hardhat, the other is called monorepo ethers, and the other monorepo subgraph. And the contract hardhat template has just the contract part. It doesn't have the front end. It's just for you if you want to work with the contracts Semaphore. And the monorepo ethers and monorepo subgraph, these both are complete applications with front-end and backend. With front-end and contracts to create entire applications. Monorepo ethers is using ethers under the hood to query on-chain data, and monorepo subgraph is using the graph protocol under the hood so that you can query on-chain data. And with the CLI, you can also query on-chain data for the groups. Like you can get group information, like the members of a group on a specific network, group information, and etc. So you can find more information about the CLI in the GitHub repository in this link. So you can see the other comments too. You can also create a project using the boilerplate. You can fork it or use it as a template. So here is the repository link, and also the boilerplate leaf app. So this is the demo. the deployed one, so you can check it out and play around with it. So yeah, you can understand more what is going on. You can also install the packages manually. Here is the link to all the packages. Just installing the identity, the group, and proof and data package to create your entire application. And yeah, this is another way. If you don't want to use the CLI boilerplates, you can just integrate Semaphore into your project like this. So I will talk about the architecture of a Semaphore application. You can create applications with Semaphore, you can create completely off-chain applications, or you can create completely on-chain applications. I will start explaining the on-chain applications, and then I will explain the architecture of the off-chain applications. So this is like the architecture for a decentralized application using Semaphore. In one part, we have the on-chain part, which contains the contracts. For this part, you will use the Semaphore contracts, and then you will add your own contracts. The Semaphore contracts will emit logs, which will be used for the front-end app to create proof and things like that. So we also have this other part, which is the off-chain part. And this part, you will have your entire web application and the front end. And for this part, you will use the identity package to create the identities. You will use the group and proof package to generate proofs, because to generate a proof, you need to recreate the group using the logs. And we also need the data package to query these logs. So we will need all these packages in the front end to have a Semaphore application. And then we will also need a relayer or a backend. You can create your own relayer, a backend for that, to send transactions so that we can keep the anonymity, and yeah, we can preserve the anonymity of the user. Then this will be the architecture for a Semaphore off-chain application. And you will need a database to store your data, the members and the signals. And then you will need a backend to query this data and send it to the user, and to verify the proof. In the backend, you will verify the proof. And then in the front end, you will generate the identity and have the group and proof package to generate the proof, which will be verified, as I said before, in the backend part. So this will be like the architecture for the off-chain application. And I would like to take some time to talk a bit about Semaphore version 4. So the version you will be using is version 3, which is already outdated. There are several projects using it, and it's already tested by many projects. But we are working on Semaphore version 4, and the alpha version is out, and it has some improvements, a lot of some new features, improvements. So I will talk a bit about some of them. So regarding the circuit, there are new names for some variables. We will have simplified identities. Also, we added circum, syntactic sugar. We also have dynamic depth now, and we will have additional circuits to use them with Semaphore. So you will have other features not integrated into the protocol, but you can use it with the protocol. We have an optimized Merkle tree. The one that we are using right now, an incremental Merkle tree, but we will have an optimized version of this incremental Merkle tree, which is called lean incremental Merkle tree. This Merkle tree doesn't have 0 hashes. It has dynamic depth, also bus insertion, and better results for JavaScript and Solidity benchmarks. You can see some of these, you can read some of these benchmarks in the reserve repo that I added the link here. And all the benchmarks are there. You can also run the benchmarks in your computer. So this new data structure is also part of the CKKit repo. CKKit is a set of libraries, plugins, algorithms, or utility functions that can be reused in different projects and zero-knowledge protocols, making it easier for developers to access user-friendly, tested, and documented libraries for common tasks. So Semaphore version 3 uses CKKit, but in the version 4, we are using it even more. And there are a lot of packages that are used in Semaphore and are part of this repository. So you can know more about it in this link, the GitHub link, so the README file. So here are some packages that you can find in this repository. So if you want to learn more about Semaphore and PSD, you can go to the website, Discord, and so here are all the links. So here is my GitHub with all my links and the PSC Discord. And thank you so much. Let me know if you have questions.
Awesome. Cheers. Thank you, Vivian. Yeah, if anybody has any questions, please feel free to type them in the chat or take yourself off mute and you can ask Vivian directly. And for those that have been maybe keeping an eye on the partnership channels in Discord, Vivian has responded to a few questions already, so you can find her there in the PSC partner channel. But yeah, if there are no questions, then thank you, Vivian, for this great workshop and presentation, and thank you everybody else for attending. We have about just a little over an hour until the kickoff for Circuit Breaker begins, so don't forget to attend that. And then we do have two other workshops later this afternoon as well. So cheers, thank you all, and yeah, have a good rest of your Friday, and happy hacking.
Thank you. Thank you.